A researcher places two colonies of bacteria into two petri dishes that each have area 10 square centimeters. After the initial placement of the bacteria, t equals 0, the researcher measures and records the area covered by the bacteria in each dish every 10 minutes. The data for each dish were fit by a smooth curve, as shown above, where each curve represents the area of a dish covered by bacteria as a function of time in hours. Which of the following is a correct statement about the data above? So here's our graph, basically exponential, and we want to figure out which one of these statements is true. So let's just start evaluating these statements. At time t equals 0, both dishes are 100% covered by bacteria. Well, they said that it was a total area of 10 square centimeters in this dish. And we can see at time t equals 0, dish 1 is 1 square centimeter and dish 2 is 2. So no, that's not 100%. They would need to be up here at 10. So we can go ahead and get rid of those. At time t equals 0, bacteria covers 10% of dish 1 and 20% of dish 2. Well, dish 1 is at 1, and that's 1 out of 10, which is indeed 10%. And dish 2 is at 2 square meters out of 10, square centimeters out of 10, which is 20%. So yes, that works. So we like B. But as always, we always check all four choices. At time t equals 0, dish 2 is covered with 50% more bacteria than dish 1. So careful, dish 2 is actually double dish 1. And dish 1 is at 50% less than dish 2. So just be careful with the ordering of that. That's not quite right. It's in the ballpark, but it just flips the relationships. For the first hour, the area covered in dish 2 is increasing at a higher average rate than the area covered in dish 1. Well, here's dish 2. In the first hour, it barely goes anywhere, whereas dish 1, it jumps up quite a bit. So the rate of change in dish 1 is much higher than the rate of change of dish 2 in the first hour, so this is not true. So the answer to this one is choice B. Occasionally, on the old SAT, they had exponential equations that you had to solve. I don't think I've ever seen a graph of one. So here we go. It's a graph. And you have to be able to figure out, or they're not all exponential, I guess. This one's quadratic, and this one looks to be exponential. But anyway, point is you got to be able to look at these graphs and interpret them based off of, again, a real-life scenario. A lot to read here, a lot to figure out, but really it's going to be, as you saw, evaluating these statements in the question itself and looking at the graph to see which statement works. So yeah, charts and graphs question. I don't think it's anything too onerous here.